for you to be able to recall. So last meeting we have talked about the behavior of the two passive elements or three passive elements that um, will be involved on our discussion. So we have the resistance or the resistor, the capacitor, and the inductor. So we also um, studied or discussed about how a sinusoid can be transformed into a phasor form and para mas madali yung ating magiging computation kasi kapag nilagyan na natin siya sa ating calculator, mas madali na siyang gawin. Yan. So, for a resistive circuit, yan. So, ang sabi nga natin, the voltage and current are in phase with each other. So, meaning, wala po tayong phase angle between the voltage and the current. Kaya naman, ang formula lang natin is V is equal to IR. Yan. So, yun yung voltage current relation nila. So, wala silang phase angle between them. If we will be talking about naman an inductor, and so kapag inductor naman ang pinag-uusapan natin for a pure inductive circuit, yan. So kung i-graph down natin siya with respect to its phasor diagram wherein ito daw yung kanyang real part tapos ito yung imaginary part. So in terms of current as our reference, yan. So the voltage leads the current by 90 degrees. Yan. So ibig sabihin, if we are going on a counterclockwise direction from our reference, that is a leading. Yan. Leading po ang ating um, gagawing notation. Pero pag baliktad naman, from halimbawa dito to a to a clockwise direction, and so that will be lagging naman. Yan. So dito, the voltage leads the current by 90 degrees or the current lags the voltage. The current lags the voltage by 90 degrees. So same approach will be used naman for a capacitor. Wherein a capacitor naman, so in terms of capacitor, ang reference natin is the voltage. And so the voltage lags the current by 90 degrees or the current leads the voltage by 90 degrees. So yun po yung ating sa capacitor naman. So this is the summary of the voltage current relationships natin as we discussed last meeting, and we also have an example wherein we applied the how to turn this sinusoid into a phasor. And so all you have to do is so phasor, ibig sabihin instantaneous form. So magiging capital letter niyan kung phasor na siya. So 12 bar angle 45 degrees, yun yung kanyang phase angle. So, and our angular frequency given na naman dito, so 60. And we have adjusted or we found out that the current will be ito, 2 cosine negative or 60t minus 45 degrees by using the formula um, from our table. Yan. So ito. So ito lang naman yung kinuha natin doon. Yan. So galing siya dito. So I is equal to V over J omega L. So ibig sabihin, from phasor, yan. So from phasor, kinonvert din natin siya into a um, instantaneous form or a sinusoid form na naka-cosine. But you can also transform this into a sine. So kayo na lang bahala kung paano nyo siya i-convert by using our sa diagram natin. Yan. So yung conversion natin, if this will be plus 90 or minus 90 degrees. Okay po tayo doon? Clear po tayo sa previous discussions? Okay. So now, let's go with our next topic. So this is part 3 of our discussion or topic. So this will be about impedance and admittance. So in the preceding section, we obtained the voltage current relations for the three passive elements as V is equal to Ri. So this is for a resistor. Then V is equal to J omega Li, which is for an inductor. And V is equal to I over J omega C, which is for capacitor. Yan. So with this, we will be able to derive the equation for the phasor current. Yan. So, i-rewrite lang natin yung formula natin in terms of the voltage or yung ratio between the phasor voltage and the phasor current. So, which is, in this case, kapag sa resistor ang pinag-uusapan natin, so that is R is equal to V over I. Then for an inductor, that is V over I is equal to J omega L. And for a capacitor, that is V over I is equal to 1 over J omega C. So from this expression, we obtain Ohm's law in phasor form for any type of element as, so ibig sabihin daw, the ratio of the phasor voltage and the phasor current is what we call now the impedance in any of the three passive element. Yan. So, ibig sabihin, kapag resistive lamang, ang Z natin is equal to R or the impedance will be equal to R. Kapag ka naman inductor, ang Z natin or impedance is equal to J omega L. At kapag naman capacitor, ang Z is equal to 1 over J omega C. Or, if you're going to get the phasor voltage, ang phasor voltage natin will be the impedance multiplied by current. Yan. So, para din naman yung Ohm's law lamang. So, di ba sa Ohm's law natin is V is equal to, I is equal to V over R. Yan. So, itong R natin, depending upon the element, kung siya ay purely resistive, kung siya ay capacitive or inductive, yan. So, ito ay papalitan natin ng Z. So, sabihin ng I is equal to V over Z. Yan. So, magdidepende na lang sa kung ano yung element na involved. Kasi later on, magkakaroon na tayo ng combination ng mga elements na yan. So, ibig sabihin, itong Z natin will not only be resistor or purely resistive, hindi rin siya purely capacitive, and hindi rin siya purely inductive. Mamaya, magiging combination na yan. So, if you are going to get the phasor voltage, that is current multiplied by, current multiplied by the impedance. Yan. So, ito lang po yung ating gagamitin. So, where Z is the frequency-dependent quantity known as the impedance measured also in ohms. Yan. So, ibig sabihin, yung value ng inductor natin at saka yung value ng capacitor, the capacitance and inductance of our elements can, di ba, ang inductor natin is measured in Henry or inductance is measured in Henry. The capacitance naman is measured in farads. Yan. So, di ba, kung ilalagay natin yan dun sa equation natin ng Ohm's law, kailangan is yung resistor natin kasi wala tayong problema kasi ohms yan. But with respect to the inductor and the capacitor, iba po ang unit niya. So we have to find a way in order for us to convert the quantity from Henry or farads into ohms. So dyan po papasok ngayon yung tinatawag nating impedance wherein naka-anchor siya dun sa ating frequency. Yan. Kaya nga sabi nito, ang Z natin is frequency-dependent quantity. Yan. So, nakadepende siya sa ating frequency. Particularly yung ating angular frequency. So, ang angular frequency naman natin is 2 pi f. So, depending upon the value of the frequency, so yun po magiging conversion natin. Yan. So, the impedance Z of a circuit is the ratio of the phasor voltage to the phasor current measured in ohms. And the impedance represents the opposition of the circuit exhibits to the flow of sinusoidal current. Yan. So, hindi na lang siya bastang current. Sinusoidal na po yung ating pinag-uusapan ngayon. So, although the impedance is the ratio of two phasor, it is not a phasor. Yan. So, kindly take note of that because it does not correspond to a sinusoidally varying quantity. Yan ha. Kasi di ba siya ay ratio. Ratio siya ng two phasors. Pero hindi po phasor ang impedance. Yung current at voltage natin ay phasor kasi di ba yun ay so kung ang voltage natin ay sinusoidal tapos ang current natin is ganyan din. So alam natin na ganyan yung magiging um, tawag dito, yung kanyang magiging diagram. But for a impedance or for an impedance, hindi po siya considered as phasor. So, ang phasor lang po natin ay yung voltage at saka yung current. So, the impedances of resistors, inductors, and capacitors can be readily obtained from equation 9.39. So, yan. So, 9.39, kung babalikan natin, so ito po yun. Yan. So, ang Z natin daw is 1 over J omega C. Tapos, ang ating Z kapag inductive ay J omega L. Yan. So, ibig sabihin, if we are going to rationalize this one, yung sa inductor, ang Z po natin dyan, kasi nasa ilalim yung J, so yan yung magiging negative J multiplied by 1 over omega C. Yan. Kaya po, kapag capacitive po ang ating magiging impedance, yan po ay magne-negative. Yan. So, tatandaan po natin yun ha. So, ito po yung ating impedances and admittances of passive elements. Kapag resistance, yan, Z is equal to R. Ang admittance naman is the inverse of impedance. So, in this case, magiging 1 over R. Tapos, ang inductor naman natin, ang impedance natin is J omega L. Ang kanyang admittance is 1 over J omega L. Then, kapag ka naman capacitor, ang impedance natin is 1 over J omega C. And ang admittance natin is J omega C. So, from the table, we notice that ZL, or the inductive impedance, is equal to J omega L, and the capacitive impedance is equal to negative J over omega C. Kagaya ng binirive ko, din eh. Yan. So, consider two extreme cases of angular frequency. Kapag daw ang ating omega is equal to 0, yan. So, ang angular frequency daw natin ay 0. For example, for DC sources, kasi hindi naman nakadepende sa frequency ang DC. Yan, natatandaan ha, ang kadepende lang sa frequency ay yung AC. Ibig sabihin, kapag sinubstitute daw natin ang ating angular frequency na 0 doon sa ating formula ng impedance, whether it is capacitive or inductive, kapag siya inductive impedance ang hinahanap natin, when we are talking about DC source, ang ZL daw natin ay magiging 0. At ang impedance natin kapag capacitive naman ay mag-i-infinity kasi nasa ilalim. So, di ba, undefined yan. So, ibig sabihin, confirming that we already know that the inductor acts like a short circuit while the capacitor acts like an open circuit. Yan. So, ibig sabihin, kapag DC po, ang pinag-uusapan natin, ang behavior ng ating impedance or ng ating inductor, siya ay short-circuited. While our capacitor naman is open-circuited. So figure 9.15 illustrates this as a complex quantity. The impedance may be expressed in rectangular form. Yan. So sabi ko nga kanina, ang i-discuss natin later on will be a combination of not just pure resistive, pure capacitive, and pure inductive. Kapag tayo nag-discuss, there will be times na ano na siya, combination na nga siya ng dalawa. So, ibig sabihin, pwede daw natin i-represent yung ating impedance in terms of the passive elements. So, we have the impedance is equal to R plus or minus JX. Yan. So, bakit po plus or minus JX? So, Si resistance, ito po ang real part ng ating complex number. Kasi di ba ito ay magiging complex number na. Tapos, ito po, yung JXL is what we call the reactance. Yan. Wherein, yung reactance natin may either be a capacitive reactance or inductive reactance. So, kapag yan ay positive, yan, ibig sabihin, yan ay inductive reactance. At kapag naman siya ay negative, yan ay capacitive reactance. Maliwanag po ba? So, yun ang tatandaan ha. So, depending upon kung ano po ang ating element dito sa reactance natin, magva-vary po yung kanyang sign. Kapag inductive, siya ay positive. Kapag negative, siya ay capacitive. But, if may combination po tayo ng inductive and capacitive, lalo na kapag siya ay naka-series, depende na po ang magiging sign kung alin ang mas malaki dun sa dalawa. So, kung mas malaki yung inductive reactance, so magiging positive po yun. Kung mas malaki naman yung capacitive reactance, eh di magne-negative po yun. So, where R is equal to RE, or the real part, times Z is the resistance, and X is equal to the imaginary, Z is the reactance. Then the reactance X is just the magnitude, a positive value, but when used as a vector, a J is associated with an inductance and a negative J associated with a capacitance. So ito yung po yung sinasabi ko sa inyo. So kapag positive, inductance, kapag negative, siya ay capacitance. Thus, the impedance Z is equal to R plus JX is said to be inductive or lagging since the current lags the voltage, while the impedance Z is equal to R minus JX is the capacitive or leading because the current leads the voltage, yeah, by a certain phase angle. And the impedance, resistance, and reactance are all measured in ohms. Kaya naman, kaya nga natin i-convert muna yung ating inductor or inductance and capacitance into its equivalent reactance kasi that is the only way that we can express those quantity into an impedance measured in ohms. Maliwanag po ba? Okay. So now, if we have here an impedance in the form of a rectangular form, R plus minus Jx, we can transform this into its equivalent polar form, wherein Z is equal to the absolute value Z or the magnitude of Z bar angle theta. So, ganun pa rin naman ang gagawin natin kung ika-calculator nyo lang din naman yan. So, i-convert nyo lang ulit. Shift to 3 lang yun. Kapag naka-mode 2 ka sa iyong calculator or naka-complex mode ka sa iyong calculator. Yan. So, comparing naman, so ito pala, kapag ka nag-convert tayo ng polar, so yun pa rin naman gagawin. Yung rectangular to polar, so ang magnitude ng ating impedance will be the square root of R squared plus X squared. Tapos, ang theta natin is the inverse tangent of X. That could be positive or negative, depende kung siya capacitive or inductive, divided by R. Tapos yan. So, R is equal to Z cosine theta and X is equal to Z sine theta. Kapag daw i-compare naman natin yung 9.41 at 9.42. So, nasan yung 9.41 at 9.42? So, ito yun. 9.41 saka 9.42. Yan. So, we can see that or we can infer that. So, ito daw yung ating ito daw yung mangyayari sa ating behavior ng inductor at saka ng ating capacitor. So, ano nangyayari doon? So, kapag ang inductor natin, kapag DC, yan, short-circuited yan. Pero kapag high frequency na yan, kapag AC, yan ay naka-open circuit naman. Then, kapag si capacitor naman, kapag DC, yan ay open circuits. Kapag short circuit, yan ay, or short circuit naman siya kapag high frequency. So, yan po yung behavior ng ating capacitor and inductor kapag siya ay ano, kapag siya ay uh, in DC or AC. Naintindihan po ba yun? Maliwanag po ba yun? Behavior ng ating passive elements. Yan. So si resistor wala tayong problema kasi either AC or DC, yun na yung kanyang um, behavior. So lagi lang siyang naka-close. Yan. So yung ating um, reciprocal daw ng impedance is what we call now an admittance. So yung admittance natin, admittance represented by Y. So from the name itself, it admits yung ating so sa halip na i-oppose niya, di ba pagka resistance ino-oppose niya. So ibig sabihin kapag ka impedance, ino-oppose din niya yung current. So pag dito sa admittance, ina-allow na. So that is the reciprocal of impedance. Yan. So kung ang unit nito ngayon is mho, yan, yung kabaliktaran ng ohm, or Siemens. Yan. Or S. Small letter S. Naintindihan po yun? Okay, so I hope the others are able to get our lesson kasi iilan-ilan lang yung nagre-react. One is answering or opening his or her microphone. I hope that you truly understand what I am talking about here because if you really don't understand this, how will you be able to answer the exam or the questions on your final exams? And speaking of exam, sino yung hindi pa pala nakakakuha ng exam? Yan. So, kailangan within this week ay makakuha ka na ng exam or else I will not be giving you any special exam. Kasi it has been more than 3 weeks or 3 weeks already since the midterm exams. So dapat you should have taken it immediately after. So it is your responsibility also, since I have already told you naman, although online kayo last week, you should have approached me if you have a vacant time and you will be able to take the exam. Dapat last week pa ay kumuha na ng exam. So I will be giving you last chance para kumuha ng exam or else you will be getting 0 for that specific exam.
Noted po, sir. Ano pong available schedule niyo po within, the week po?
As much as possible, sana bukas ka makapag-exam eh.
Mga what time po, sir?
Nandito naman ako sa school ng 7 to 7. Kasi may klase naman tayo bukas. Diba face to face tayo bukas?
Yes po.
Ayun.
Sige po,
Dapat
sir.
bukas makakuha ka na ng exam. Si Miss Puebla lang ang hindi pa nakakuha ng exam, wala nang iba.
Si Mr. Liberal din po.
May siya, sige. So dalawa kayo. Basta bukas dapat makakuha na kayo ng exam.
Noted po, sir. Thank you po.
Okay. So yan. So that will be for our admittance. Okay. So yan. So the admittance Y is the reciprocal of the impedance measured in Siemens or S or yung ating representation niya. So the admittance Y of an element or a circuit is the ratio of the phasor current through it and the phasor voltage across it. So kabaliktaran na nga lang naman ito ng impedance. So di ba ang impedance natin is the ratio of the phasor voltage uh, and the phasor current. So the admittances of the resistors, inductors, and capacitors can be obtained from equation 9.39 and they are also summarized in table 3. So as a complex quantity, yan. So ang kapag ka represent natin yung admittance natin, yan. So we have wait lang ha. Yan. So since ang impedance natin, yan, so 'di ba ang impedance natin is R plus or minus JX. Yan. At kapag ka in-inverse natin yung ating impedance, ang 1 over Z is equal to um, dito. Ang 1 over Z natin is equal to the admittance Y. Yan. So what we will do now is kagaya nito. Yan. So as you can see here, syempre, may equivalent din kapag inireciprocal mo itong dalawa. So kapag ka ang reciprocal ng ating resistance is what we call conductance. So this is what we call the conductance or G. Yan. And kapag ka ang ating reactance naman ay magiging beta or what we call the susceptance. Yan. So yan ha. So yun yung dalawang reciprocal nung ating resistance at saka reactance. So kapag ka, yan, katulad nito, yung ating conductance plus J susceptance is equal to 1 over R plus JX. So by rationalization, yan, so kung i-rationalize natin daw siya, so ang gagawin mo lang dyan is i-multiply mo itong um, nasa right hand side ng ating equation ng tawag dito, conjugate ng ating denominator. So pag sinabi natin conjugate, papalitan mo lang yung sign noong ating imaginary component. So kapag nangyari yon, so ito na yung magiging ano natin, magiging r minus jx over r squared plus x squared. And so equating the real and imaginary parts, kapag daw kukuhanin natin ang ating value ng g, yan. So, ang g natin is equal to r over r squared plus x squared at ang beta natin is negative x over r squared plus r squared, showing that g is not equal to 1 over r. Yan. So, mangyayari lang po ito. So, di ba ito ay ang conductance natin ay magiging 1 over r kapag ka ang x natin, yan, ang x natin is equal to 0. Dito lang po magiging equal ang conductance natin dito sa value na ito. Pero, kapag we are talking about tawag ito, complex na, wherein meron na tayong reactance at saka yun nga, reactance. So, kailangan masatisfy itong given na to. Take note that the R and X are just the magnitudes or the value lamang, yung numerical value lang niya. 'Di ba yung reactance natin ay may J, so hindi nyo yun isasama. Kasi ito po ay ano lang, purely a number. Wala siyang kasamang imaginary sign or J or I for this specific. So yun ha. So ito po yung ating gagamitin para makuha natin yung ating conductance and susceptance. Yan. So say for example, para mas maintindihan natin, find V of t and I of t in the circuit shown in figure 9.16. So we are asked to find the sinusoidal current and the sinusoidal voltage of this circuit. So paano daw natin kukuhanin yun given that we have the voltage source which is equal to 10 cosine of 40. We have a 5 ohm resistor and a 0.1 farad capacitor. So, before we solve this, I will give you a 5-minute break muna. So, water break lang. Then, we will be back after 5 minutes. Okay? Then, we will solve this problem. Okay pa? Okay. So let's continue with our discussion. Are you still there, guys? Are you still with me? Okay. So yan. So we will now be solving this problem. We're asked to find the value of our voltage and current. So para mas madali, so this is just a simple series circuit wherein we have a voltage source, a resistor, and a capacitor. Ayan. So given naman yung mga values natin, so all we have to do is to find our current. So paano natin yun kukuhanin? Yan. So ang voltage na hinahanap, yan, yung V of t natin dito is ito. Yan. Kasi 'di ba voltage source naman aring isa. So ang hinahanap natin dito is yung voltage dun sa ating capacitor or the voltage across the capacitor. So we can call this as V of t. Yan, for that matter. Yan. So ano muna una natin gagawin? So since ito ay naka-sinusoid na form, so pwede natin muna siyang i-convert into its equivalent phasor. Yan, para mas madali kasi 'di ba kapag kumuha tayo ng current mamaya, so pwedeng ang or magagawa lang natin yon yung current, yung phasor current kapag ka naka-phasor din yung ating voltage. So paano natin i-convert into its equivalent phasor voltage? Sige nga, kung matatandaan yung discuss natin last time, how are we going to convert this into phasor? Anyone? So, di ba yung ating voltage source is equal to 10 cosine. So, since it's just 40, pwede yung cosine omega t or cosine 40 plus 0 degrees. So, di ba ganyan lang yan? So, 0 degrees lang siya, volts. So, paano natin siya i-convert into phasor? Yes, Mr. Kara. Hmm. Ano yun? Medyo ano yung sound.
R equals 10 po. Tapos V equals RI bar angle theta.
Okay, which is simply, so, sabi ko sa inyo kapag ka-phasor ng pinag-uusapan natin, so, capital VS is equal to, so, 10, yung kanyang amplitude, bar angle, kung ano man yung angle na dito. So, in this case, in 0 ang angle, so that is 0 degree volts. So, yan. So, ito po yung ating magiging phasor voltage ngayon. Now that we already know the phasor voltage now, so ito, problema na lang natin is yung ating impedance. So, ang impedance natin, sabi nga natin kanina when we discuss is R plus or minus JX. Where R is the resistance, so given na tayo ng 5 ohms, and X is the reactance, which can be either capacitive or inductive. So in this case, we have a capacitive reactance. So in order for us to get the value of XC, yan, that is 1 over J omega C. Yan. Which is in this case 1 over J times, so what is our omega here? What is the value of our angular frequency?
Four po.
Okay, so we have 4 times the value 0.1. So our capacitive reactance is equal to, kindly compute. Paki-compute nga. Paki-input sa calculator. Yan ang lalabas.
Negative 5 over 2J po.
Okay. Negative 5 or negative J 2.5. Tama. So that is now in ohms. So therefore, the value of our impedance is equal to the resistance, which is 5 minus J 2.5 ohms. Yan. So ito po yung ating value ng impedance. And if we are going to solve for the value of our um, current, so ang ating I or ang ating phasor current now is equal to the voltage over the impedance. Yan. So which is equal to 10 bar angle 0 divided by 5 minus J 2.5. So what is the value of our phasor current? Ito'y by ohms law lamang ha. What is the value?
1.6 plus J 0.8 po.
Ano? Come again, come again.
1.6 plus J 0.8 po.
1.6 plus J 0.8 ohms. Okay. Or, ohms hindi. Amperes to, sorry. Amperes. Or, kindly convert this into polar form. So in polar form, that is 1.7889 bar angle 26.5650 or 5651 degrees ampere. Tama? You follow? Okay, so ito ba yung ating final answer for value of current? So ito na ba yung gagamitin natin or ito na ba yung ibabox ko? Ito na ba yung ibabox? Itong answer na ito? So, saan sagot ay? Oo, hindi. Is this our final answer for Karen?
Di pa po.
Okay, so hindi pa. Because we are asked to find the value of the or i-represent it as sinusoid. So, ibig sabihin, ang I of t natin, kung susundin natin yung ano natin dito, so that is 1.7889 cosine of 40 plus 26.5651 degree. For 26.5651 ampere. So this is our final answer for the current. Do you follow? Okay. Now, so we are asked to find the value of the voltage across the capacitor. So, paano natin kukuhanin yung voltage across the capacitor? So, di ba, If you will remember, ang voltage natin is I multiplied by Z. Where ang Z natin, where Z is equal to 1 over J omega C. So substituting that to our voltage, that is the current multiplied by 1 over J omega C. So, if you are going to substitute our answer, so that is current in sinusoidal form, so that is 1.7889 bar angle 26.5659 degrees divided by J times omega is 4 multiplied by 0.1. So therefore, the voltage across the capacitor, so let's represent this as Z or V of C is equivalent to, I compute, so what is the voltage across the capacitor? So what is the value of our voltage? The phasor voltage. Sorry, naka-off pa lang mic ko. Yan. So, ito yung ating magiging final answer ng V of t or yung ating sinusoidal form ng voltage natin. And if you're going to graph, so ito yung ating current. Yan. Kasi positive yung angle niya. So, counterclockwise direction from cosine. So, ito yung ating cosine omega t. Yan. So, ito yung ating 26 degrees. Yan. So, ito ito yung 26.5651 degrees. Tapos, sa kabila naman, so ito yung 4.4723. Then, ito yung ating angle. So, on a clockwise direction, kaya yan ay negative 63.4349. So, kapag pinag-add mo yung dalawang yan, that is 90 degrees. So, tama naman kasi, bakit? So, kapag babasahin natin ito, paano natin siya babasahin? So, di ba, yung current, yan, leads the voltage by 90 degrees. Yan. So, di ba, leading siya. Yung current natin, mas nauna siya ng 90 degrees with respect to voltage. Which is, kung babalikan natin yung ating diniscuss last time, yan, kapag ang pinag-uusapan natin ay capacitor, ang current ay leading sadya ng 90 degrees with respect to the voltage. So, ibig sabihin, tama yung ating solution. So, 90 degrees apart po yung current and voltage. At leading. So, ibig sabihin, I of t leads V of t by 90 degrees. As expected for a capacitor. Kapag ang involved natin ay capacitor. Do you follow? Any questions? Question po before we proceed to the next.
Nan po.
About the others. Bakit iilan ang nasagot sa inyo? Ang sabihin nahihiya pa din kayo, ilang weeks na tayo nagkaklase. Tsaka pwede kang i-minimize natin ang pagre-react ng mga gayaan. Hindi naman ako nagla-live selling eh. Pwede naman kayong mag-type sa ating chat box. Tsaka yung pag-react nyo ng thumbs down, parang although ang tanong ko ay kung may question, pero parang hindi siya parang hindi siya hindi applicable na gawing reaction yung thumbs down. So, yun nga, hindi naman ako nagla-live set. Kung siguro may value yung pag-react nyo yan, kung ako-convert sa pera yan, kahit mag-react kayo ng mag-react, walang problema. Pero as much as possible, pwede namang sumagot, open your microphone, tapos ay o kaya naman mag-type sa chat box, open naman yan. Anyways, sa inyo naman yan. So, yun. So na-confirm natin dito that the current leads the voltage by 90 degrees. Okay? So, yan. So, another example. So, kindly try this one. So, ito naman ay inductor or inductance naman yung given natin. So, pakitry muna nito. I will give you 20 minutes para isolve yan. So, we are also asked to find the value of the voltage and current. So, hinahanap ulit natin is ito, saka ito. Yan. So, kindly try. May sagot na? May sagutan ba? One with solution or answer? Uy, imik naman kayo. Everyone, please turn on your cameras. Paki-open lahat ng camera para kita kung sinong na-attend o hindi. Bakit wala akong makausap sa inyo? Yan, kagigising lang yata. Yung iba, bakit hindi kayo makakausap? Anong problema? Naintindihan niyo ba ang aking dinidiscuss?
Yes po.
Ay, ba't parang wala yata wala akong nakakukuhang response sa inyo? So, solve ba yung iba? Meron namang sagot. Yes, Miss La Puebla.
IT is equal to 2.5 cosine 10t minus 60 degrees amperes. And ang voltage po or VT ay 5 cosine 10t plus 30 degrees voltage po.
Hindi. How about the others? Yes, Mr. Karan.
Ang IT po ay 10 cosine times the quantity of 10t minus 30 degrees amperes.
30. Hindi rin. How about the others?
Ang I po ba sir ay 4.47 10 2.43 ampere.
Okay, 4.472 sine 10t plus 3.43 amperes. Tama?
Tama po.
Okay. How about the voltage?
Wait lang po. Ikaw po.
Sige. So, yun. So, in terms of sine, ang current natin will be 4.472 sine 10t plus 3.43 degrees ampere. Yan. So, ito yung magiging sagot natin. So, kung i-convert mo ito papuntang cosine, that is 4.472 cosine of 10t. So, ano magiging ano na rin? From sine, gagawin natin siyang cosine. So, this is, say for example, this is your cosine omega t. And this is your sine omega t. So, from sine, gagawin mo siyang cosine. So, that is 3.43
Minus 90 po.
So this is minus 90 degrees. So therefore, this is 4.472 cosine of 10t minus minus ano? 82.57 degrees amperes. Or hindi. 86 pala. 86.57. Tama.
Yes po.
Okay. How about the voltage? Ano ang magiging sagot natin? I-represent nga pala natin. So, are yung mga, yan, 3. So, dapat ay, so, saan siya mapapapunta? Kung sine yun, so mali pala ikot natin, ano? Kasi ay sine, ito ang sine natin, diga. So, dapat ay positive 3. Nandito siya. Yan. Ano yung 3 degrees natin. Tapos kung papunta siyang cosine, dapat ay paparne. Yan. So, ano yung cosine natin. Yan. So, 90 degrees. Yan. So this is 86, 157 degrees. So how about the voltage?
Sir, is it ano po? 8.944 cosine 10t plus 3.43 degrees.
Anong value mo? 8.944
Cosine 10t plus 3.43 degrees po.
Okay. Okay. So we have 8.944 sine. Cosine yung kanya. Cosine 10t. So ang V of t is 8.944 cosine of 10t plus
43 po.
3 degrees volts. Yan. Okay. So, ito naman yung nakasign ano. Yan. Or, kung in terms of sign naman, so paano naman ito natin i-represent in terms of sign? So, kung cosine 3 point something siya, so nandito dito siya ano, 3.43. Ano naman siya, positive 3. Tapos papuntang sign, so dapat ay plus 90. So, magiging 8.944 sine 10t plus 3.43 plus 90. So therefore, ang V of t natin is 8.944 sine 10t plus 93.43 degrees volts. Yan. So either of the two, pwede nyo namang gamitin. Yan. So, maalin dito sa dalawang ito. So, paano nangyari yun? So, parehas lang din naman ang solusyon natin kanina dun sa um, capacitor. Pero ito nga lang ngayon, so ang phasor natin dito, ang Vs natin is equal to, so this is 20 angle, positive 30 degrees volt. So, yan, yung ating phasor voltage. Tapos, ang impedance natin, so kailangan natin kuhanin si X sub L, which is equivalent to omega L or 2 pi FL. Yan. So, yung 2 pi F, equivalent yan sa omega. So, ang omega natin dito, kung kukuhanin natin siya dito sa ating voltage source, ito yung ating omega. So, di 10 multiplied by 0.2. So, ano yung ating X sub L? Ang value ng X sub L natin. 2.
2.
So that is 2 ohms. Yan. So therefore, ang impedance natin is the resistance. This is inductive reactance, so plus JXL. So which is 4 plus J2 ohms. Tama? Then if we are going to get the value of the current, so that is I is equal to Vs divided by the impedance. So that is, anong Vs natin? 20 bar angle 30 divided by 4 plus J2, in which you will get 20 angle 30 divided by 4 plus 2i. So we have 4.4641 plus J 0.2679 amperes. Or in polar form, that is 4.4721 bar angle 3.4349 degrees ampere. Now, hindi tayo nagbago ng sinusoidal form dito kasi inas-is natin siya na sine. So therefore, kung i-represent natin to in terms of the current, sinusoidal current form, so that is 4.4721, which is ito, sine 10t plus 3.4349 degrees ampere. So kaya ito po yung ating naging sagot. But pwede nyo naman nga siyang i-convert papuntang cosine. So kung i-convert natin siya papuntang cosine, so nandito siya, pabalik lang. So magma-minus tayo ng 90, kaya magiging negative 86.57. So kung halimbawa, or tapos ang voltage naman natin is equal to Z multiplied by I. So that is J omega L multiplied by I. So that is J times or J2 for this, ano na lang, for simplicity, J2 na lang siya, diretso. Times, ang current natin ay yung 4.4721 angle 3.4349. So the voltage now sa capacitor sa inductor natin is equivalent to, so we have 0.5358 or 5359 plus J 8.9282 volts, or yung 8.9443 bar angle 93.4349 degrees volts. Wherein, kung i-convert natin siya into a sinusoidal form, so that is 8.9443 sine of 10t plus 93.4349 volts. Yan. So, volts. This is our answer in terms of sine. But also, you can represent this as cosine. So, yung kabaliktaran naman nito. And, kung i-graph natin siya, yan, kung in terms of sine, so di ba nandito yung cosine natin, nandito yung sine natin. So, ang una is 4.7 sine D ito. Yan. So, nandito na siya. Halimbawa, ito yung 3.4349. Tapos, yung isa is 93. So, so saan yun pupunta? Di na eh. Ano? So, 93. Ito yung 93 natin. Pamula dito. Yan. Tama? So, pamula dito sa umpisang ito. So, 93.4349 degrees. And the difference between the two, so ito yung ating I of t, ito yung ating V of t. So, since this is an inductive circuit, so ano naman yung diniscuss natin last time? So, balikan natin ulit. So, kapag inductive circuit naman daw, yan, the current lags the voltage, or the voltage leads the current by 90 degree. Leading daw ang voltage, which is tama naman dito. Kasi ang voltage natin ay nandito eh. Yan. So, leading siya ng 90 degrees with respect to current. So, yan. So, kapag on a counterclockwise direction. So, that proves, or as expected, yung voltage natin leads the current by 90 degrees. Any question? Any questions po?
None po.
None. Okay. So, yan. So, that is how we solve for the value of our current and voltage for a simple circuit pa lamang yan. So, simple circuit pa lang to ha. Okay, if there are no other questions, then let's proceed with our next topic. So, we have Kirchhoff's laws in frequency domain. So, we cannot do circuit analysis in the frequency domain without Kirchhoff's current and voltage laws. Yan. So, di ba nung discuss kayo ng inyong AC circuit, ng DC circuit, diniscuss nyo yung Kirchhoff's law. Tama? Na-discuss ba sa inyo yun? Okay. So, yan. So, we need to express them in the frequency domain. So, for KVL, let V1, V2, up to Vn be the voltages around the closed loop. So, then, so, diba, ang sabi nga natin, that is the summation of the voltage drop and rise on our circuit. Sa loop na yun. So, V1 plus V2 plus Vn is equal to 0 daw. Then, in the sinusoidal steady state, each voltage may be written in cosine form, and so that the equation becomes, yan, so ang Vm1, so ginawa niyang phasor. So, di ba ito ay naka-instantaneous or yung ating sinusoidal form, ginawang instantaneous. Kaya naging Vm1 cosine of omega t plus theta 1 plus Vm2. Ibig sabihin ng M doon is maximum kasi di ba yung ating sa instantaneous yun ay naka maximum value or yung amplitude niya. Yan. Plus and so on and so forth is equal to 0. So this can be rewritten as, kung i-rewrite daw natin yun, yan, so that is Re times Vm1 e raised to j theta 1 times e raised to j omega t. So ito yung ginawa natin last time. So ipapattern lang natin dyan, or yan, common naman yung itong mga to. Yan, yung common yung e raised to j omega t tsaka yung Re. So inilabas lang yan. Then if we let V of k is equal to Vmk e raised to j theta k, then so yung ating real times V1 plus V2 plus Vn times e raised to j omega t is equal to 0. Because e raised to j omega t is not equal to 0, then ang V1 plus V2 plus Vn is equal to 0, indicating that the Kirchhoff's voltage law holds for phasor. So ito lang daw yung gagawin natin kapag phasor na yung ating pinag-uusapan. So that is still the summation of the voltages across the elements ng ating kung ano man yung element doon sa ating circuit. And by following the similar procedure, we can show that Kirchhoff's current laws holds for phasor. And if we let current I1, I2 to In be the current leaving or entering closed loop or surface in a network at time t, Then, so I1 is equal, or I1 plus I2 plus IN is equal to 0 if I1, I2, and IN are the phasor forms of the sinusoids I1, I2 to IN, then, yan. So, ito lang din naman yon. So, the current or the phasor currents, kapag ka ang gagawin natin is Kirchhoff's laws, is just the summation of the phasor currents. So, once we have shown that both KVL and KCL hold in the frequency domain, it is easy to do many things such as the impedance computation, the nodal analysis, the mesh analysis, superposition, and source transformation. So, yan yung mga na diniscuss nyo last time dun sa DC circuit. So, dito sa AC circuit, mag-nodal analysis din tayo, mag, tawag dito, mag-mesh analysis. Kaya dapat tandaan nyo pa rin yung mga methods na yon. Maliwanag po?
Yes
Maliwanag
po.
po ba yun? Okay. So, yan. So, paano naman daw kapag ka yung combination na ng impedance ang ating isosolve? Yan. So, di ba, meron tayong configuration last time sa DC natin wherein yung ating resistances are connected in either series, parallel, or delta Y combination. Yan. So, ganun din ang gagawin natin dito sa AC. So, ngayon nga lamang, ang ating pinag-uusapan na are impedances. Yan. So, hindi na lang siya purely resistive. So, impedance na. So, consider the N-series connected impedances shown in figure 9.18 and the current flows through these impedances are the same. Yan. So, ang characteristics kapag ka series connection, yan. So, sa series connection, so series connected impedances, kagaya nung series connected resistances, ang current ay equal. Meaning, yung total current natin will be equal to the current that will be flowing through impedance 1, equal din siya sa current na impedance 2 up to kung ilan man yung impedances na given sa atin. Yan. And, in terms of voltage naman, yung total voltage natin is the summation of the voltages drop or rise across each. Yan. So, ibig sabihin daw, kung kukuhanan natin siya ng, so di ba, total voltage, ang V can be represented by IZ1 plus, ito ay IZ2 plus IZN. Yan. So this can be represented as capital letter I or yung total current multiplied by Z1 plus Z2 plus Zn. So therefore, kapag daw ang ating impedances are connected in series, ang total impedance daw natin is just the summation of the individual impedances. Yan. Or yung ating Z equivalent. Maliwanag po ba?
Yes po, sir.
Okay. Then, so showing that the two or the total or equivalent impedance of a series-connected impedances is the sum of the individual impedances, dissimilar to the series connection of the resistances. So wala naman silang pinag-iba. So if n daw is equal to 2 or the number of impedances natin ay 2 shown in figure 9.19, the current through the impedances is, so makikita natin is, ano rin naman yun? The same. Now, so ang current by Ohm's law is just that total current is equal to the voltage source divided by the sum of the two impedances given. And because V1 is equal to Z1 times I and V2 is equal to Z2 times I, then pwede natin daw sabihin by voltage division, yan, so voltage divider theorem, na kapag kukuhanan natin ng voltage ng voltages across the impedance 1 and 2, ito daw lang yung formula. So that is, kapag kukuhanin natin yung V1 is equal to Z1 over Z1 plus Z2 times V ang V2 naman natin is equal to Z2 over Z1 plus Z2 times V. So, anong tinatandaan ko lang dyan? Ang tinatandaan ko dyan, kapag halimbawa, kukuhanin ko yung V1, so kapag kukuhanin ko yung V1 natin, di ba, ang multiplier natin is the total voltage V. Tapos kung ano ang subscript na rin, di ba 1 yan. Ibig sabihin, yun din ang impedance dapat na nasa itaas. Kaya ito ay 1 din. Divided by the sum of the two impedances. So same dito, kung V2 ang hinahanap ko, kailangan ng impedance ko na nasa ibabaw ay 2 din. Ha? Yun ang tinatandaan ko kapag voltage divider theorem or voltage divider relationship. So in the same manner naman, we can obtain the equivalent impedance or admittance of the n parallel connected impedances as shown in figure 9.20. So the voltage across each of the impedance is the same naman. So ang characteristic naman kapag parallel connected impedances is that ang voltage total is equal to the voltage across the impedance 1 equals sa voltage across the impedance 2 at equal yan kung ilan mang impedances ang connected in parallel. So, ngayon, ang current naman daw natin is equal to the current that will be flowing through the individual impedances. And since ito daw ating current, yan, ating I total is equal to, kung i-represent daw natin ito, that is V over Z1, kasi total naman yun, plus V over Z2, plus kung ilan man yan, so V over Zn, we can see that ang 1 over Z total is equal to 1 over Z1 plus 1 over Z2 plus kung ilan man niyang impedances in parallel. Yan. Or, ang equivalent natin is equal to 1 over 1 over Z1 plus 1 over Z2 plus 1 over Zn, which is also equivalent sa admittance. So, di ba, ang 1 over C is admittance. So, ibig sabihin ng Y total is equal to Y1 plus Y2 plus Yn. Yan. So, yan po naman ang ating equivalent impedance kapag parallel ang ating impedances. Maliwanag po.
Yes po.
Okay. So, kapag naman daw, dalawa lang yung ating given na impedances, so dito naman papasok yung equivalence natin na product over sum. Yan. So, product of the impedances divided by the sum of the impedances. Yun daw yung kanyang equivalent. Parang sa resistance lang din. Product over sum lang yung gagamitin. Tapos, since ang maghahati-hati naman dito ngayon is current, so gagamitan naman natin siya ng current divider rule. Yan. So, kung current divider rule naman, ang tinatandaan ko lang dyan is kabaligtaran naman. So, kung ano ang subscript na rin, current na hinahanap mo, dapat yung kabila ang nasa ibabaw. Yan. So, halimbawa, ang hinahanap ko is current through impedance 1. So, dapat ang impedance ko sa ibabaw ay 2. And divided by the sum of the impedances times the total current. Kung I2 naman ang hinahanap ko, dapat Z1 yung nasa itaas. So, yan lang po yung tatandaan natin kapag voltage divider and current divider theorem. Maliwanag po. So, ito naman ay parang review lang nung nakaraan ng discussion. So, I hope ito ay na-discuss sa inyo. Tama po ba? Can you recall doon sa DC inyo na na discussion about series parallel, current and voltage divider theorem?
Yes po.
Okay. So, yun pa rin naman yun. Ang kaibahan nga lang dito, sa halip na purely resistive na lang yung ating circuit, so ito ay naka-impedance based na. So, impedance based na po ang ating gagamitin. Okay. Then, we also have our delta to y and y to delta transformation. So, ito naman ay ano din, hindi ko na ito i-derive. So, kapag ka y2 delta, so ito ang ating given, yung 1, 2, 3, yan. Tapos ang kukuhanin natin is yung ABC. So, kapag gagawa kayo ng kanyang ng connection, ang tinatandaan ko lang dyan, yun naman ay kahit ikutin nyo. Kung gusto nyo nandun yung 1, nandun yung 2, nandun yung 3, walang problema yon. Pero, yung corresponding niya, dapat opposite niya, yun din yung A. Katulad na rin. Kung nandito na ang C1 ko, nandito din dapat yung A, yung katapat niya, yung opposite. Kung are ang 2 ko, are dapat ang B ko. Kung are ang 3, ay di yun, nasa taas. Pag pinaikot mo yan, ano ba, ito ang ginawa mong 1, ay di dapat are ang A mo. Kung are ang 2, are ang 2, are dapat ang B. Tapos kung are ang 3, are dapat ang C. So, it's up to you kung paano nyo lalagyan ng notation yan. Pero, kapag ginamit natin yung transformation, ano ba, kukuhanin ko yung si A. Yan. So, ang tatandaan nyo lang dito is, para makuha yung equivalent, that is the sum of the product of adjacent sides taken two at a time, yan, divided by the opposite. Yan. So this is y2 delta. So sum of the product of adjacent sides taken two at a time. So ibig sabihin, kung halimbawa, di ba 1, 2, 3 yon. So product ng 1, 2 plus product ng 2, 3 plus product ng 1, 3 divided by ano yung opposite ng 1, ng A na hinahanap natin. So, dapat yun ay Z1. So, ganun lang po ang tatandaan kapag Y2, delta. Then, kapag ka delta to Y naman, delta to Y, so kapag delta to Y naman, ay di, um, so delta, pupuntang Y. So, halimbawa, Z1 naman ang hinahanap natin. So, product of adjacent sides divided by the sum of the sides. Yan. So, ibig sabihin, kung ito yon, kung ito nga hanapin natin Z1, so ang Z1 ko ay ZB times ZC divided by summation nito, yung ABC. So, yan lang po ang tatandaan nyo kapag ka delta to Y and Y to delta transformation. Nare-recall? Nare-recall ba yung delta to Y, Y to delta?
Yes po, sir.
Yes po.
Okay. So, with that, itry natin. Yan. So, ito naman, kung balance delta ulit, kapag ang delta Y natin ay balance, so, ibig sabihin, ang impedances nun ay magkakapare-parehas, ito lang yung gagawin natin. Ang equivalent ng delta connected ay equal lang sa 3 times ng Z ng Y. Or, kapag ZY naman at delta ang given, 1/3 lang nun ang ating magiging Y connected impedances. So, ito lang ang gagawin natin. Okay. So, kung halimbawa itong gagamitin natin, find the input impedance of the circuit and assume that example 9 operates at on ang angular frequency is 50 radians per. Yan. So, paano daw ito natin? Paano daw natin to tawag dito, isi-simplify. Ang hinahanap natin is the input. So, ibig sabihin, ang hinahanap natin is Z equivalent. Yan. So, ano yung ilang impedances meron tayo dyan? Sige nga. Sa tingin nyo, ilang impedances ang meron? Ilang impedance combinations ang meron tayo dyan? Ilan? We have ilan? Ilan lang meron tayo dyan? So we have... Uy, ilan? Bigay ng bilang kahit mali.
Tatlo po.
Okay, so tatlo. Alin-alin yun? So, di ba, ayun ay R at saka X or C or L. So, we have 1. Ito yung Z1 natin. Tapos, ito yung Z2. Tapos, ito, since wala siyang kasamang resistance, considered pa rin yan as impedance Z3. Yan. So, now, para makuha natin yung impedance 1, so that is R, tapos inductor yon, so plus J XL. Yan. So, kuhanin muna natin yung XL1. So, that is, ano yun? So, 2 pi F L or omega L. So, that is, ano yung omega natin? So, 50 daw yon times, ang L is 0.2. So, ang ating XL1 is equal to, ano yan? Medyo compute nga. Ang value? 10.
10 po.
Okay. So, this is 10 ohms. So, therefore, ang ating Z1 is equal to 8 plus J10 ohms. Yan. Next, how about kay Z2? So, ang Z2 naman is a capacitor. So, that is R minus JX C. But in terms of XC, that is 1 over J omega C. So, that is 1 over J times, anong omega natin? 50 times 10 milli. And milli is negative 3. So, what is our X sub C? X sub C1. Anong value nun? Anong value niya?
Negative, negative
Ha?
J2 po.
Negative J2. So, this is negative J2 ohms. So, therefore, ang ating Z2 is equal to R, which is 3 minus J2 ohms. Ito yung ating 2. And lastly, si Z3 is equal to R. Capacitor ulit yun, so dapat maging X sub C2. So, ang ating X sub C2 is equal to 1 over J omega C. So, that is 1 over J times 50 multiplied by 2 times 10 to the negative 3. So, what is our XC2? This is negative J. Ano yun?
Negative J10
Negative
po.
J10. Okay. Negative J10 ohms. So, therefore, ang impedance natin, so 0 naman yung ating resistance, is just negative J10 ohms. Now, so i-redraw natin yung ating circuit in terms of our impedances. So, ang impedance natin will be, ito yung ating Z3. And ito yung ating impedance 2. And this is our impedance 3. So this is Z2 and this is Z1. Now, so if you're going to find the Z equivalent, paano natin siya isi-simplify? So, paano natin isi-simplify yan? Anong connection natin dyan? Sige nga. Ano yung mga connections natin dito? How are these impedances connected?
Parallel po yung
Sige.
Z1 and Z2, tapos yung result po nun ay series circuit po with Z2.
Okay, so therefore, ang equivalent circuit natin is Z1 parallel kay Z2 and series kay Z3. Okay, so simplify muna natin yung Z1 and Z2. So, Z1 parallel kay Z2 is equal to, so since parallel yan, two impedances, pwede natin gamitin yung product over sum. Yan. Which is, anong Z1 natin? So, this is 8 plus J10 times 3 minus J2 divided by 8 plus J10 plus 3 minus J2. So, ano yung equivalent nito? Pakiano nga. What is the value? So, yung naka-ano muna, yung whole value ng ating ilagay. Ano yung whole value? Huwag muna tayo mag-round. Ng value natin. Anong value? Pa-calcu. Input lang sa calcu yan.
$596 over 185 minus J198 over 185 po.
185 ohms. Okay. Then, our Z equivalent now is equal to negative J10 plus 596 over 185 minus J198 over 185 ohms. So, our Z equivalent is equal to so, anong value natin? Pwede na siyang i-ano. So, we have 596 over 185 minus 2048 over 185 ohms. Tama? Or 3.2216 minus J 11.0703 ohms. So this is our Z equivalent. Do you follow? Any questions with regards to simplification or simplifying series parallel connected impedances? May tanong po ba?
Yun po.
How about the others aside from Miss La Puebla? How about the 35 other 34? Okay. Try nyo nga are. Sige, mamaya pala yan. Ito muna. Yan. So, ngayon, we are asked to find the value of VOT in circuit 9.25. So, as you can see here, iba na yung connection natin. Yan. So, hindi na siya yung typical na single loop na ano lang. So, ito ang hinahanap natin, V of T. Yan. So, paano daw natin siya masosolve? So, to do analysis in the frequency domain, we must first transform the time domain circuit, itong figure na to, into phasor equivalent ulit. Yan. So, paano natin? So, kailangan natin munang i-convert ito papuntang phasor at saka papuntang impedances. Kasi di ba ito ay naka-farads pa, tapos aring isa ay naka-Henry pa. So, hindi naman pwedeng mag-solve tayo na nakaganyan yan. Kasi dapat ang impedances natin ay naka-ohms. Diba? So, naka-ohms siya dapat. So, in this case, i-convert muna natin itong mga to. So, in terms of the voltage source, yan. So, ang voltage source natin is 20 bar angle negative 15 degrees volts. Yan. So, ito yung ating voltage source. Wherein, ang omega natin dito is 4. So, kita naman din eh. So, ang angular frequency natin is 4 radians per second. Now, so convert muna natin itong ating mga element dito. Yung, kuhanin natin yung x sub c. So, ito ay 1 over omega c. So, that is 1 over 4 times 10 times 10 to the negative 3. So, ano ating x sub c? Paki-compute nga. Ang sagot. What is 1 over 4 times 10 to the negative 3?
25 po.
So, 25. So, ibig sabihin, ang ating x sub c is negative j 25 ohms. So, how about our inductance? So, one natin yung capacitive. That is omega L. So, that is 4 multiplied by 5. So, our XL is 20 ohms or J20 ohms. Liwanag po?
Yes po.
Okay. Then, i-transform natin into a circuit. Circuit natin will be, so kung i-convert natin siya papuntang circuit, so this is our resistor, then this is our capacitor, and our inductor. Yan. Wherein this is J20 ohms na kasi naka reactance na tayo. This is negative J25 ohms. And this is where our VO lies. And this is our 60 ohms. And our 20 bar angle negative 15 degrees. Yan. So, ang pinapahanap na sa atin is the voltage across the 20 or the 20 ohms reactance. So, paano natin siya kukuhanin? Yan. So, any idea kung paano natin isosolve yung V sub 0? Sige nga, any idea lang. Sige. Anything na natatandaan nyo kung paano mag-solve tayo dito? Or yung mga properties or principles na pwede nating i-apply kung paano natin yung masosolve. Paano yun? Ano ba? Paano natin siya masosolve? Okay, so by looking at our circuit, kung mapapansin nyo, pwede ba nating i-simplify yung circuit natin without compromising yung value na hinahanap natin? Sige nga. Katingin nyo.
Pwede po siguro i-parallel yung dalawa po. Yung negative J25 at J20.
Bakit? Bakit pwede natin siyang galawin? Ay, nandito yung ating V sub 0 sa J20. Ano mangyayari doon sa V sub 0? So, anong principle ang pwede nating i-apply doon? So, ano ba yung connection ng 25 at saka 20? Anong connection ni J25 at ni J20?
Parallel po sila.
Parallel. So, anong meron kapag parallel ang dalawang impedances? Anong property? Or ano yung characteristics ng parallel connected na impedance na diniscuss natin kanina? Yun nga. So, di ba nag-discuss tayo kanina kapag parallel connected impedances, ang ganito ay ganyan. Ano yung kanina diniscuss ko? About parallel impedances.
Same po yung voltage nila.
Okay. So, di ba? So, since parallel itong dalawang ito, ibig sabihin, RAVO din. Yan. Pwede rin natin sabihin na nandito yung VO. Meaning, pwede natin i-simplify itong dalawang ito. So, kung isi-simplify natin yan, so ang Z natin, let's call this halimbawa ZX is equal to negative J25 parallel kay J20. So, anong magiging value ng JX natin? Sige nga, compute. So, ano magiging equivalent no? Yun nga.
J100 po.
So, di ano magiging negative. So, negative J25 times J20 divided by negative J25 plus J20. So, ang x natin dito is positive J100 ohms. Tama?
Yes po.
Okay. So, ibig sabihin, ang circuit natin ngayon will be ito na lang. Yan. Tapos ito na equivalent. So, since positive na yan, so lalagyan na lang natin is ganyan. Hindi naman siya impedance na ano eh. Kumbaga. So, paano natin i-represent yun? Sige. Represent na lang natin siya as ganito. So, since impedance na yan. So, this is J100 na ngayon. Tapos, ito pa rin yung ating 60 ohms. Tapos, ari yung ating 20 bar angle negative 15 degrees. Yan. At nandito pa rin yung ating V sub 0. Yan. So, ngayon, so this is just a simple series circuit. Yan. So, kung series circuit yan, natahanapin mo ng voltage ito, ano yung pwede nating i-apply sa kanya na theorem?
Voltage division principle po.
Okay. So, ibig sabihin, pwede nating by applying voltage divider rule or voltage division rule. So, kung hanapin natin ito, so let's call this V sub 0 is equal to the total voltage times, so that is Z1 or Z2 over Z1 plus Z2. So, which is 20 bar angle negative 15 multiplied by, ano yung Z2 natin? So, yung ating J100 divided by 60 plus J100, which will give us the final answer for V sub 0 equivalent to so anong value natin ng VO?
17.1499 or angle 15.9638 po.
17 point ulit
1499
199
or
angle
angle 15.9638.
38 degrees volts. Or, kung gagawin natin siyang sinusoidal, so ang ating VO of V is equal to 17.1499. So, since nag-convert tayo kanina, this is in terms of cosine, hindi tayo nagbago. So, cosine na rin ang gamitin natin din eh. So, that is cosine. Ang ating omega is 4. So, that is 40 plus 15.9638 degrees volts. So this is now our final answer. Any questions? May tanong po ba about doon sa problem na yon? Or naintindihan ba yung ating sample problem? Paano ang pagsasolve? Walang response. Violent reaction. Okay. So yan. So paano naman daw are? Sige nga, i-try nyo nga ito. Find the current I in the circuit. So yan, ang hinahanap ay current I. So ibig sabihin, naka-phasor naman. Okay, try nyo nga muna are. Yan, kung paano nyo siya i-solve. So, anong connections ng ating mga impedances diyan sa given circuit natin? What is the connection? Pwede ba natin i-simplify yan ng diretso? Ha? Kasi di ba current lang naman yung hinahanap dyan. So, sabihin, kung current lang yung hinahanap, so ang current natin is equal to the voltage source divided by the total impedance lang. So, kung kukuha naman siya ng total impedance, tatanggalin mo lang ang source, yung input impedance dito is the simplified or equivalent nitong circuit. But, ang tanong, ano yung connection ng ating mga impedances dyan? Is it a simple series parallel lamang? Ha? Is it a simple series parallel lamang?
Opo.
Bakit? Bakit no? Ano yung connection natin dyan? Sige nga, tingnan mo nga. May mai-simplify ka ba dyan ng mga impedance? May masisimplify ka bang impedance? Iyan. Yes or no? May simplify ba? Yung direct simplify na ano lang.
Kaya po ata i-delta Y po yung yung part na may sa node B at C po.
Okay. So, ibig sabihin, hindi mo siya pwedeng basta simpleng series parallel. Tama? Kasi, ang circuit natin ay delta and Y connected. So, makikita mo naman yan. Kasi diba, yan, yung tatlong nodes natin, so hindi naman are ito isang impedance, diba? Ang mga impedance natin are Z1, Tapos array Z2, array Z3, tapos array Z4, tapos Z5, and Z6. Yan. So, hindi mo naman pwedeng i-directang i-series array yung 2 and 5 kasi meron ka din eh. Yan, meron ka din eh. Tapos ito naman, hindi mo siya pwedeng i-parallel directly kasi yan yung combination nito. So, ibig sabihin, ang i-apply nyo dyan is the principle of delta y transformation. So, mamimili ka lang, it's up to you na kung saan yung iyong i-convert. So, halimbawa, yes, Miss Sambat. Any question, Miss Jenny? Okay, so mamili na lang kayo kung alin yung gusto nyong i-convert. So, pwedeng itong 2, negative J4, 8 at saka J4. Anong connection na rin? Anong connection nito? Ito, ito, at ito. Anong connection niya? So, di ba yan ay delta connected. So, pwede nyo yung i-convert. Pero, ang ginagawa ko dyan, itong nasa gitna agad ang aking i-convert. So, ito, yan, itong part na to. Itong J4, 8, at saka negative J3. Yan. So, di ba, Y connected, Y or T connected. So, yan ay magkakaroon ng, ano din eh, yan. So, yan. So, ganyan yung magiging connection. So, itong combination na rin, magpaparallel siya din eh. Tapos, ito, magpaparallel siya din eh. Tapos, yun, simple ano na lang yan. Ari magiging series, tapos magpaparallel, tapos magsi-series. Tapos yun, kukuha mo ng I. So, itry nyo nga yan. So, any way naman, pwede nyo gawin. Pwedeng ari ang i-convert nyo, ito. Diba ito ay delta? Ito, isang ito. Yung 8, 8J6, saka yung negative J3, delta connected yan. So, pwede mo naman yung i-garni. Yan. Ari yung yan. So, bahala na kayo kung anong gusto nyo i-convert. Kung saan kayo mas madadalian. Sige nga, try nyo nga yan.
Ano? Wala na yung laman. Ha? Kayo rin.
Kaya labes ang iyo. Yan, dapat kaya labes ang iyo.
No?
Hindi kaya labes mo pa yung nasa ilalim na yun.
Ano ga?
Yung, kanina yung bilog na yung maliit.
Ano bilip mo?
Yun! Yung maliit mong mesa.
Ang ganun lang ako. Sabihin mo.
Masa na yung buksan?
Okay, so kindly continue this problem. So, paki-solve. I-try nyo muna to sa bahay. Then, didiscuss natin siya tomorrow since we are on a face-to-face naman bukas. So, mas maganda kasi mas may paliwanag ko kung paano siya so-solve. Okay? Tapos, meron pa, wala na pala. Ito na pala yung last natin na problem. Then, yung next natin na topic is about, ano na, think network analysis na yung sunod natin. Yan. So, sinusoidal steady state analysis na. So, yun ay yung nodal and mesh analysis na. So, we will be discussing that tomorrow. Okay? So, kindly continue this muna. Then, if you don't have any questions, then that should be all muna for today. Then, see you tomorrow. Okay na. Thank you.
Thank you.
Thank you po, sir.
Thank you po.
Thank you po.